So let's try solving this equation here. We have x, y's, and z's. We choose which one that we would like. Now evaluating this, I have y's and then the z's. Those look pretty nice, but the nice thing about the y's here is that they all have the same coefficient of 2. And so this is probably the nicer one than z, because looking at the y's, I don't have to multiply at all. So let's start with that. Let's do equation 1 and equation 2. This is negative and that's positive, so that's perfect. So let me use equation 1 and 2. I'm going to add them together. So I add them together, I get 4x. My y's cancel, my z's cancel, and that equals negative 4. So solving for x, I get x equals negative 1. So it's a little different than our last example. We already get a variable, but once you use two equations, you still have to use that last equation we haven't used yet. So we have to use equation 3. We need two variables first before we can start to plug things back into the original. So we have to use equation 3, and we have positive 2y. Which one does that go better with? Well, we want the opposite sign, so we're going to pick equation 1 again. So again, I'm using a new equation, equation 3, that one I haven't used yet, and I'm going to combine that with equation 1, so that way I don't have to multiply anything. So equation 3 is negative x plus 2y plus 4z equals negative 9. Then I'm going to add equation 1 to it. X minus 2y plus z equals negative 11. So in this case, my x's cancels, my y's cancel, so I get 5z equals negative 20 divided by 5, so z equals negative 4. So that's really nice. So now I have two variables. So once I have two variables, I can go ahead and substitute into an original equation. So I'm going to go ahead and substitute this into, let's say, the last equation, equation 3. So negative 1 plus 2y plus 4 times negative 4, and that equals negative 9. So negative becomes a positive 1 plus 2y minus 16 equals negative 9. 1 minus 16 is negative 15 plus 2y equals negative 9 plus 15. So 2y equals 9. Negative 9 plus 15 is 6. Now I divide by 2, so y equals 3. So now I have all three variables, and now I'm done. So x is negative 1, y is 3, and z is negative 4. So let's try some special cases, solving a three-variable system. So we have equation 1, equation 2, and equation 3. Now, all day in class, I think a lot of students were picking equation 1 and equation 2. We're eliminating y because it's nice because we just have y, and so that's fast to change. So let's do equation 1 and equation 3. Now, in order for it to eliminate, the y's to eliminate, I have to multiply by a negative, so I have to distribute that to each and every term. So this becomes negative x minus y minus z equals negative 2. Then I'm going to add equation 3 to it. 4x plus y minus 3z equals negative 6. So then this becomes 3x minus 4z equals negative 8. So I use two equations. I have to use equation 2. So with equation 2, which one is the nicer one to use? And I think the nicer one to use in this case will be equation 1. So I want to go ahead and eliminate that with equation 1. I'm trying to eliminate y, so this is a positive 5y. I need a negative 5y. So to change that, I multiply this entire top equation 1 by negative 5. So that's negative 5x minus 5y minus 5z equals negative 10. Then I add that to equation 2, right? Oh, I was using these equations. So equation 2 is 5x plus 5y plus 5z equals 3. Now, when you add this together, you'll notice this is 0, 0, 0, 0 equals negative 7. So this is no solutions. Okay, so it's a special case. So this is solving a three-variable system with no solutions. Pause the video and try this next example, and I'll have the answer for you when you come back. Okay, if you try this out, I went ahead and eliminated x's So I multiplied the top equation by negative 4x because I wanted it to be a negative 4x and a positive 4x. So I multiplied all the way through. Then the bottom one, I just used equation 2 and added it together, and I got 0 does not equal 2, so this is no solutions. One last example, solving a 3-variable system. So we did one solution, no solution, so I think you can imagine what this one will be. So let's go ahead, let's see. In this case, our z's are really nice, so let's eliminate z's because they're all 1 and then they're positive and negative, so that's kind of fast to have to do. So let's do equation 1 and 2. Let's add them together. X minus y plus z equals negative 3. X minus y minus z equals negative 3. Adding it together, we get 2x minus 2y equals negative 6. Then I have to use equation 3. And so since it's positive z, I want the negative z, so I'll do equation 2. So this is x minus y, this is equation 2, equals negative 3. Equation 3 is 5x minus 5y plus z equals negative 15. So this becomes 6x minus 6y equals negative 18. So now we just choose which variable we want to eliminate. So this is much like the first example I did earlier. So let's eliminate our x's. So if this one is a 6x, we need this to be a negative 6x. So our goal is to get negative 6x. So I need to multiply this by negative 3. So this is negative 6x plus 6y equals positive 18. Then I rewrite this below. 6x minus 6y equals negative 18. So this, I get 0 equals 0. So this is infinite or infinitely many solutions. Now really there's a lot more work that needs to go into this, but for now, just for this class, I'm going to go ahead and stop there. Go ahead and try example number 3, pause the video, and when you come back, I'll have the answer for you. All right, you tried this out. You added equation 1 and 2 first to eliminate the y's, and so I got 2x plus 2z equals 16. Then I had to use equation 3, and I used that with equation 2 because the y's would cancel out without having to multiply. And I got 3x plus 3z equals 24. Now you could multiply, but another thing that you could do just as an option is you could divide by numbers. So if I see this, I can divide by 2, and that would get a regular x. If I divide this by negative 3, I would get a negative x, which also cancels. So I just wanted to show you this to give you another option. The other option is, of course, multiplying this by 3 and multiplying this by 2 or negative 2, and that would eliminate as well. But when you do this, you would get 0 equals 0 at the end, and again, infinitely many solutions. So the last thing you should try is solving the system using the substitution method. So what I would do, number 1, is to plug in this z into here. When you plug that z in, you'll find this y value. Once you find that y value, you can plug in the y and the z in here and figure it out. So pause the video, and then when you come back, I'll have the answer for you. All right, so I'll work this one out with you just to kind of help you out. So z is 5, so I'm going to plug it in. So this is going to be y plus 2 times my z of 5, and that equals 13. So y plus 10 equals 13, subtracted 10. So y equals 3. So I know z is 5, y is 3. So now I'm going to plug both of those in into the top equation to find x. 2x minus 3 times 3 plus my z value of 5, and that equals 10. So 2x minus 9 plus 5 equals 10. 2x minus 4 equals 10. Add 4. I get 2x equals 14, or x equals 7. So the solution is 7, 3, 5. So I hope this helps out. Thanks for watching.